welcome back. This is lesson 11.6 journal welcome or volume of prisms. I will be able to correctly calculate the volume of a prism. That's what it should say right here. Sorry. Of a prism. That's a typo. So vocabulary for this lesson. A solid figure. A solid figure is a three-dimensional figure. Base of a solid figure is a base shape. So the basic shape that you see. Prism has two bases and all the other lateral faces are rectangles. And volume is the space inside a figure or how much space, three-dimensional space, an object takes up. So we learned this song with the last one. But let's do it again. The volume of a prism, this is sung to Camptown races. So we're going to fill in volume of a prism. Easy, easy. First you'll need to find the length and the height of that base. So you got to find the base shape. So length and height of that base. With that area, because you're going to find the area, so the length and height of the base, get the area of that base, and then you're going to times it by the height. The height is the length from base to base. Put a correct label in place. So, the song goes like this. Volume of a prism, easy, easy. First you need to find the length and the height of that base. With that area, times it by the height. The height is the length from base to base. Put a correct label in place. Okay, if you'll kind of follow that idea, it makes finding volume super easy. So the base shape of this is a rectangular prism. The base shape would be a rectangle. So area of that base shape, that would be, we can pick any of these rectangles since they're all rectangles. I'm going to pick the bottom. So I'm going to do 25 times 20. So 25 times 20. So the area of that would be, well, 2 times 25 is 50. So that would be 500 centimeters squared. That's the area of the base shape. The height from base to base. So the bases are congruent to each other. So from here to the other base that's exactly like it is a distance of 4. So the height from base to base is 4 centimeters. So we find the area of that base, which was 500, and times it by the height, which is going to give us 2,000. And because we're now into volume, this is going to be centimeters cubed. So see how we went? This was centimeters and centimeters. That's where centimeters squared came from. Then we times it by 4 centimeters, which is going to give us centimeters cubed. Okay, volume is so much easier than surface area. Let's try this one. So what is the base shape here? This is a triangular prism, so that means our base shape is a triangle. So the area of that base shape, so we're interested only in the triangle. So area of that base would be 16 times 12, but because it's a triangle, we're going to cut it in half. So 16 times 12, 2 times 6 is 12, regroup 1. 2 times 1 is 2, plus 1 more is 3. 0 placeholder. 1 times 6 is 6. 1 times 1 is 1. Add it up. 2, 9, 1. But that is just this, so we get 192. Now we got to divide that by 2. So 192 inside the box, divided by 2. 2 goes into 2 goes into 19. 9 times minus 18 gives me 1. Bring down the 2. 2 goes into 12 6 times, minus 12 gives me 0. So, height from base to base. Oh, sorry, we gotta finish this. So this is 96 centimeters squared. That's the area of just a triangle. Now we gotta find out the height from base to base. So from triangle to triangle, that's 10. So that means the volume is the area of the base shape times the height from base to base, which is 10. So that tells us our total volume is 960 centimeters cubed, because we're now in volume. We've multiplied by centimeters once, twice, 3 times. 960 centimeters cubed. All right, let's go to the next page. So here we have the base shape of what? Well, this is a trapezoid. So our base shape is a trapezoid. So the area of that base shape, well, let's remember how to do a trapezoid. Trapezoid's a freakazoid. First you have to add the bases of the trapezoid. So we've got 5 and 8. So first you have to add the bases. What's that you say? I said first you have to add the bases. Weird, I'll do it anyway. Then times the height. Which one's the height? 5 or 5.8? It's going to be 5 because 5 makes the right angle with these two bases. So times the height, divide by 2. That's all that's left for you to do. All right, let's do the math. This becomes 13. 13 times 5, divide by 2. 13 times 5 is 65. 65 divided by 2. 2 goes into 6 3 times. Minus 6 gives me 0. Bring down the 5. 2 goes into 5 2 times. Minus 4 gives me 1. Decimal point, bring down a 0. 2 goes into 10 5 times. Don't forget that decimal up here. Minus 10 gives me 0. So in other words, the total area just of the trapezoid is 32.5. What unit are we working with? Centimeters squared. Now what is the height from base to base? So on this trapezoidal prism, I'm going from trapezoid to trapezoid, which is a measurement of 6.3. 6.3 centimeters. So find the area of that base, which was 32.5, then times it by the height from base to base, which in this case is 6.3. 32.5 times 6.3. 3 times 5 is 15. Regroup 1. 3 times 2 is 6, plus 1 more is 7. 3 times 2, not 3 times 3 is 9. 0 placeholder. 6 times 5 is 30. Regroup 3. 6 times 2 is 12, plus 3 more is 15. Regroup 1. 6 times 3 is 18, plus 1 more is 19. Add that all up. 5, 7, 9 plus 5 is 14, regroup 1. 1 plus 9 is 10, regroup 1, that leaves us with 2. And we have 1, 2 places behind the decimal. That gives us 204.75. 0.75, we're dealing with centimeters, now we're in volume. That would be cubed because we times by another measurement of centimeters. Okay, if you can find the area of any of these base shapes, which is why we spend so much time learning how to find those areas, you can find the volume and the surface area rather easily. Okay, let's try this one. It says Marty is pouring a rectangular concrete slab for a flagpole. It will be 2 1/3 feet wide, 3 1/2 feet long, and 2/3 feet tall. He ordered 6 cubic feet of concrete. Will it be enough? Explain. Well, if it's a rectangular concrete slab, our base shape is a rectangle. So how do we find the area of a rectangle? Well, length times width. We have a length and we have a width. So we're going to do the area of that base, so 2 1/3 times 3 1/2. So I'm going to make these into improper fractions to make this easier to multiply. 2 times 3 is 6, plus 1 more is 7, so this is the same as 7/3, times, this would be the same as 7/2, times across the top, we get 49 over 3 times 2 is 6. Well, what does that mean? That means 6 goes into 49. So 8 times, because 8 times 6 is 48. So 8, and that would leave us with one piece left over. So the same as 8 1/6 feet squared. So that's feet squared. We're not done. We need to find the volume, not just if we were making it flat. This would be flat with no depth. We are going to be doing how tall it is from base to base. So from the bottom to the top of that rectangle, it's going to be 2/3 of a foot tall. So the height from base to base is 2/3 of a foot. So volume is the area of that base shape, which we found, 8 1/6, which, because I'm multiplying again, I'm going to use the improper fraction form of it. Times it by the height, which is 2/3. Cross cancel where I can. 2 will go into 2 one time. 2 will go into 6 3 times. Times across the top, I get 49 over 3 times 3, which is 9. Now we're trying to decide if 6 cubic feet of concrete will be enough. 9 goes into 49 how many times? Well, 9 times 5 is 45. So that would be the same as 5. And then that would leave us with 4 pieces left over. So 4/9. And that would be feet cubed. If he ordered 6 cubic feet of concrete, will there be enough? Yes. Because 5 4/9 is less than 6. So he will have enough to build his flagpole. Okay, let's try this one. Jill is making a rectangular cake. Her pan is 9 inches wide and 13 inches long. She has 292.5 cubic inches of cake batter. What is the minimum height of the cake pan? So if we're going to fit all that in there, we know the base shape is a rectangle again. So the area of our base shape, well, 9 and 13. So 9 times 13 is going to give me an area of, I don't know that off the top of my head, so 9 times 13 here. 9 times 3 is 27, regroup 2. 9 times 1 is 9, plus 2 more is 11. So that's 117 inches squared. That's the area of the base shape. So we're trying to find the height from base to base. We don't know it, but we do know that she has this many cubic inches of cake batter. So in order to fit her cake, we know the volume is 292.5. And we know to find the area, or the volume, we take the area of the base shape, which we know is 117, and we times it by the height from base to base. Problem is, we don't know that height right now. Oh, you can't even see what I'm doing. I'm sorry. So volume was this, is equal to the area of the base shape, which is where we got 117 from, times the height from base to base. So we're trying to figure out how tall the pan is to fit the cake batter. So how can I undo this and figure it out? Well, this is timesing. So to undo timesing, I can divide. So if I divide by 117, I'm guessing 2 or 2.5. So let's see. 292.5 divided by 117. I know it's only going to go in 2 times. 117 times 2, 14, regroup 1, 2 times 1 is 2, plus 1 more is 3, 2 times 1 is 2, So that's 234. 2 minus 4 I can't do, so I'm going to borrow here. That gives me 8. 12 minus 4 gives me 8. 8 minus 3 gives me 5. 2 minus 2 is 0. Okay, bring down the next thing. 585. I'm guessing where that ends in a 5. I'm going to times this by 5 and see what happens. 117 times 5. 5 times 7 is 35. Regroup 3. 5 times 1 is 5. Plus 3 more is 8. 5 times 1 is 5. Oh, that worked out nice and perfectly. So that tells me that in order to fit the cake batter, the pan has to be at least 2.5 inches tall. Now, why is it not inches squared or cubed? Well, I'm looking for a height, which is a one-dimensional measurement, so that's why it would have to be 2.5 inches tall. Can you rate yourself on this concept? How do you feel about volume? 0, 1, 2, 3, or 4. Take pictures and turn them in on Google Classroom.